Guys, good morning, everyone. Hello, Karthik, Pranav, Upesh. Okay, good morning. Okay, I think you can hear me, right, all of you?
Yes, sir.
Okay.
Yes.
So all of you start your this one, that Azure Databricks. I hope you can see my screen also.
Yes, sir.
Okay. Please start that Databricks. This one. Databricks. This whatever I am starting, you can also start. Have you started? Even create cluster also. Go to compute. Okay, in the compute, just click on create compute. Compute means you are creating a clusters with 2 nodes. Okay, you can give any name like my cluster. And anyway, it's a runtime version of their Databricks, and we get 15 GB RAM. Okay, which is a community edition. So you can click on create cluster. So it takes few minutes to create a cluster. So you can just see here that it is a 15.3 GB memory we can use. We can optimize this much memory. And I think yesterday we have seen about architecture of, say, Databricks, basically. When you say an architecture of Databricks, the top layer is a cloud layer through which you can interact with their platform. Okay, while interact, this is what I can say cloud layer. Through this cloud layer, what you can do, you can upload your data. Okay, through cloud layer, you can also create a cluster that's using compute. You can schedule your job also. Okay, you can schedule your job and you can write a query. Whatever query you have, you can write a query also. Now, since you are, this is a community edition, you cannot schedule the job because you need a premium edition. Since it's a free edition, they don't allow. If at all you want to schedule a job and all, you should come through the Azure, because they provide you. I think this is very, very latest I'm talking. ADB, we call it. ADB. ADB means Azure Databricks. It's very latest, okay, where industry is using for this Spark. And this is a cloud-based platform. It's not on-premises. It's a cloud-based. You are accessing this entire cloud through the internet only. So middle layer is very important. That's what I said, a Spark. Like we are going to study a Spark. So middle layer is a Spark architecture they follow and Spark framework they follow. When I say a Spark, I think we have seen an architecture of very high level architecture of Spark we have seen. Okay, the first is a core Spark. When you have a core Spark, then on top of that we have an ecosystem, okay, such as Spark SQL, Spark Streaming, Spark Emblem, and graphics. So core Spark, when you're working with a core Spark, we are clearly working with the hardware. Okay, we are very close to hardware. That's what we create an array, which is distributed across all nodes in the clusters. And we hold the data in array, and we can access data through the array without any data structure. Now, later, if at all we want to access same data through data structure, like I need a column name and all those things. So in that case, they introduce a new ecosystem that's a Spark SQL. Through Spark SQL, you can say import data coming from RDBMS. Okay, you can import data from coming from RDBMS. You can also export data from Spark into RDBMS also. It is similar to like how you do in Scoop in Hadoop. The same way you do here as well. Okay, through you can execute a query, you can import and export it through between RDBMS and SQL. You can do it. Now the trend was moving towards streaming. Okay, today is a streaming era, like where data is coming continuously. So we have to take a data continuously to get that. Bring the data which is coming from the like web server. Okay, so web server and all we have, right? That Kafka is one which which passes streaming data. So if I want to take a data through Kafka and push into a Spark, we use a ecosystem called a streaming. Then for a machine learning, especially for a data scientist and all, if they want to use machine learning libraries, so they can also use the machine learning library of Spark. And graph analytics can also be done. Okay, like if I want to find out the shortest path, okay, in you know that in quantitative techniques or statistics, you do that node 1, then node 2, which is like if I want to come from, say, like Swargate to your place, okay, like the training place. So which is the shortest way? So that all we can find out through the graphics. These are all ecosystems. Okay, so this is part of a middle layer in Databricks. Okay, everything is there in the bottom layer. Okay, bottom layer is a storage layer where you can store your data. When you store your data, it is similar to your HDFS. Okay, it's similar to your HDFS only. Like we know that in Hadoop, right? We have bottom layer, we store our data, and through a Spark SQL Hive and all, we access the data. So like here, data get distributed across 3 nodes, 3 blocks. Each block replicates 3 times and all. The same way here also it does. So data, whenever we move our data, so it will be there here in this place. Okay. So since it's a cloud, they use a storage place like a S3. Okay, storage, they use a S3 bucket. Okay, S3 bucket means it is a S3 is a storage service given by AWS. Okay, you can store unlimited amount of data, but in this community edition you can't. You cannot store unlimited amount of data, but they have given you some space to store data. Right, so that is there that is also S3 is it's a storage account which is stored in as part of AWS. Now we are focusing more on what you can, whenever you want to keep your data locally, you can keep your data here, okay, which goes to actually S3 bucket. And this data, if you want to bring to distribute and perform a task and all, I can bring the data over here. Yesterday, we know that we have uploaded some data from my laptop into this area. That's what through data we have uploaded data. It comes over here. Okay, it is actually when it comes here means it goes to a S3 bucket, right? And this data, whenever I'm going to use like a Spark or sc.text file, okay, then it means I'm bringing data over here, and the query anyway I am firing through the worksheet. Right. So this is what how Databricks architecture would be. Now, just quickly what I wanted to do. Anyway, you know that we have a current version of Spark. Current version of Spark is 3.6 actually. Current version of Spark is 3.6. A lot of changes took place. There are a lot of changes took place from Spark 1 to Spark 2. Okay. In Spark 1, okay, when I say Spark 1, they started with the core Spark in the beginning. Okay, they started with the core Spark in the 1.0 till 1.0. They started with only core Spark. Okay, only core Spark, no, no any ecosystems, right? When you are talking about a core Spark here, okay, so we know that we are closely working with the hardware, okay, where we are going to create a array that is called a distributed array. That's called what? A distributed array. So we know an architecture of Spark, right? So what is this node called? What is this node called? The first node, like name node na in Hadoop. So here is what is the name of that node? What is this node? Yeah.
Spark Master.
This is called a Spark Master. Okay. Spark. Okay, this is called a Spark Master. Okay, then here, and these are all called, these three nodes are called what?
Spark worker.
They are called as Spark workers. Okay, Spark workers. Now, here there is a driver program resided here. Driver program resided here. And here there is an executor which executes your job. Okay, which executes a job. Okay. Now, anything you want to run a query. Okay, we submit a query. Whatever query we write, we submit where? So we submit it to Spark Master. Okay, Spark Master, we submit a query. So this query, whatever query we write, like maybe like yesterday, whatever the filter query, all those that whatever those are all set up query. So when you submit this query, so query will distribute across all nodes here. That query get distributed across all nodes. But when you are going to distribute here, anything you start from here is that's called an entry point. That's called a Spark context. There's an entry point called what? A Spark context. So when you use a Spark context, you have to use any command for the Spark context. Like if you want to read any data, if you want to write data, if you want to do any transaction, any operations and all. So here it's you have to use a SC. Okay. That is called a Spark context. So in short form, we put it as a SC. That's what yesterday we have seen, SC dot text file. SC dot text file, we use it. So we are going to use it. Second, as I said, when they introduced later stage in 1.6, they introduced what? A Spark SQL. Okay, this is what they introduced, a Spark SQL. When I say a Spark SQL, we can use with the structured data. We can use with the structured data. For that, this would be a part of a core Spark. Okay, main is a core Spark. Here is an ecosystem. So now here also they use one entry point that's called SQL CTX. That's called a SQL context. Okay, now SQL context is a sub-program of a Spark context. Spark context is main. Okay, and SQL CTX or SQL context is a part of Spark context. Now, suppose so that we can read data from any database. In the same way, Hive CTX. Okay, Hive CTX is another sub-program or sub-class which is part of a SC. So this is used basically whenever you want to read a data from Hive catalog. We used to use like a Hive CTX, right? So it means that here there are three contexts. First, whenever I want to work with the core Spark, I have to use the SC. Whenever I want to work with the Spark SQL, I have to use the SQL CTX, which is part of SC. Whenever I want to read a data from Hive, I have to use the Hive CTX, which is part of SC. Which is part of what? SC, it means Spark context. So it's difficult to remember when to use what. When to use what. So this was there. This kind of challenge was there till 2.0 version. Okay. In 2.0 and later, Okay, 2.0 and later, they have combined, merged this all three context into one. Okay, so that's called a Spark session. Spark session, we can call it. So this is a combination of SC, that is Spark context, and also it's a SQL context. That's what. So in Spark context, in short form, we use what a SC, right? So in SQL context, we use a short form as a SQL CTX. Okay, whenever I want to read a data from any database, we use. Then we use a Hive context. Hive context in short form, we use a Hive CTX. Hive CTX, we use it in short form. So it means that they have merged all three contexts into one context that's called a Spark session. Now, this Spark session in short form, okay, short form is a Spark. Short form is a Spark here. Okay, when you use a Spark, through Spark you can create RDD. Through Spark you can create a SQL context. Through Spark you can read the data from Hive also. Just only one method they created. That's what this is there after 2.0. Okay, after Spark version 2.0. Okay. After 2.0, so they introduce only one session, that is Spark session, and everything you are working, if you want to work with the RDD, you can work with the RDD very closely. But today, everyone is working with maximum data frame. Everyone is working with a data frame. Okay, what is data frame? Because if I ask you that it's that people who are coming from a non-programming background, for them it's very, very easy. Okay, where I can have data frame, where I can have a data structure, plus I can have a data also. So data frame means data frame equal to data structure plus RDD. Earlier we were using only RDD without any data structure. Now we are adding data structure to that RDD. Okay, we are adding data structure to that RDD. That's called a data frame. So data, we know that RDD, right? So RDD, which is used to, whenever suppose if I have a data over here in the source, okay, I have a data. Whenever I read a data, it can be anything. Okay, when I read a data, so what I do that I create a RDD which is distributed across all nodes in the cluster. Okay, so now data get distributed to all nodes here. Then if I perform any transformation operations on that, so we create another RDD on top of this. Again, it is distributed across all nodes. Like suppose if I filter data, so I will create a new RDD because filter is a transformation operation which creates a new RDD. Then suppose after that, suppose if I perform some kind of some more operations like count operations, sorry, not count operation. When I use join operations, distinct operations and all, so again we create one more RDD here. Okay, one more RDD here. Right. So if we are creating three RDD bottom layer, which are three different array we are creating, which is distributed across all nodes. But we do not have any data structure here. We do not have any data structure. So now using Spark SQL, what we do that we can create a data structure here. Okay, we can create a data structure. Means when I say a data structure, we will create a column name, column type, column width, everything we define here. And this is a data frame. This is what I can call as a data frame. Data frame, I think in Python, have you used pandas?
Yes, sir.
In pandas, you create a data frame, right?
Yes, yes.
Right. So what is the data frame? How do you define data frame?
PD.data frame.
That is a definition, but what is data frame?
It's combination of rows and column.
Combination of rows and columns. Okay, means it is like a table, right? It's like a table, but that data frame is not distributed. Okay, what happened that when you create a data frame in Pandas, it creates a data frame using that library. Somewhere else it allocates a memory space, bottom layer. Okay, and this data frame is obviously this data frame is pointing to here because it has to allocate a memory space, right? Somewhere else. Okay, now this holds only a schema definition. Okay, what is schema definition? This schema definition means only structure. Okay, maybe a customer ID, customer name, customer income. But somewhere else it allocates a bottom layer, some space to hold the data. Now your data is here. Okay, when you create a data frame here, what happened that you are accessing through data frame only. Everything you are accessing through data frame. Okay, when I am accessing through the data frame, so here we have what say ID is there, which is of integer type. Okay, name is there. Okay, which is of character type. Maybe a location is there, which is a character or string data type. But this is only a data structure. Okay, this is do not hold any data. Okay, this do not hold any data, but your data is somewhere else at bottom layer. Somewhere else it's a bottom layer, that is array actually. Okay, somewhere else it is supposed to hold the data, some memory location is there. So that data structure is pointing to this particular location. Okay, pointing to this particular location. This is actually your data is there here. And your data is there means when you read a data, it will fetch data here. Okay, it will be storing actual physical data is here. And your logical structure is here. And you are pointing that data through this. You are accessing anything through this data frame only. But you are actually pointing to this location from where data you can pull. You can pull a data from bottom layer. But this data frame, when you are using a Python, okay, when you're using that Python, that data structure or data frame is not distributed across all nodes. So now this is what say here, this is a distributed here at bottom layer. In Spark, that's the difference. Okay, because in Python, you are using only one machine. Only one machine you are using, and that is on single machine. But here on multiple machines, because you are using a multiple nodes here. Okay, and here also you create a data frame. Okay, and that data frame is pointing to this location. Pointing to this location, but this is distributed. Here in Python, it's not a distributed. This is the difference between the data frame which is used in Python as part of Panda library, and here when you use a Spark data frame, if you use, so this data frame is distributed across all nodes in the cluster. Okay, all nodes in the cluster here, right? So here also the data get distributed, but this is on one machine. Here data get distributed across all nodes in cluster. Okay, that is the difference. So now, as I said, whenever I'm going to use a Spark session, okay, we use directly a data frame. Today, even if you are going to work with a machine learning, okay, you have to work machine learning with the data frame only. Okay, earlier in the before 2.0 version, we were working with machine learning using RDT. But today's version, we are working with the machine learning using data frame. Now, how to create data frame here? The next question. Okay, how to create a data frame? It's very simple. So now when I go to this place, okay, now we have already created, I have already created a cluster is already created here. Okay, so cluster is my running. Now, simple example I'll just show here. If I want to create a data frame, let me go back to one create notebook. Okay, so I'll give a notebook one, my notebook. I use a notebook, my NB. Today is 18/12. Right, I'm using a Python. Then attaching to running cluster, this one. Click create a cluster. So this is my notebook. Now you know that my data, right? So data somewhere else I have stored. Okay, I have stored a data. How to see the data? Go to data, go to click on create table, click on DBFS, file store. In the file store, we have a tables here. Okay, so now I have some files which is in CSV format. I have a file in some kind of a text format. I have files, okay, which is a kind of a just a delimiter one. Delimiter file is there. So I want to read these files, right? Then let me just yesterday's that purple cloud. If I want to read it, does not have any column. It does not have any, because that is just a plain data is there, like some 4 lines are there. Suppose if I read that file, okay, this is my file. I'll take this particular part here. Okay, I will just, it's very simple to read it. So how I do it? I'll go to my notebook. I'll go to my notebook here. Okay, so here what I do simply, my data frame. Okay, let us take my data frame equal to Spark. Okay, Spark is an entry point I said. SC was used for a RDD. Now, this is a commonly used for what? Say, for both purpose. Data frame purpose, even I can use if I use like collect here, it shows data which are there in the RDD. Now, suppose Spark dot read. Simply, I'm going to read a data. Okay, what is that file name? I can use simply, if it is a CSV file, the comma separated value file, I can use simply this path. Okay, I can use a path here. Simply this much only. Right? Spark.read.csv. When I say CSV, the comma separated value. When I run this one, okay, since that purple code do not have any, say, columns which are delimited, there is no column as such. You know that already we have seen purple cow, right? That file is just having a 4 lines. Okay, that's just having a 4 lines are there. So in that 4 lines, okay, I am reading. When I'm reading these 4 lines, okay, it's unstructured data, but here I'm going to read like a data frame which has a structure. Okay, automatically what it does, it takes by default as a single column. Okay, you can just see here, go to, okay, second line, my df dot. Here also, this is a data frame. When I'm having a data frame, we have again operations on the data frame. Okay, these operations are divided into 2 types, like whatever we have seen yesterday, transformation operation and action operations, right? Suppose if I want to simply count, my data frame dot count. If I use, so what happened here, it will just give like a 4. Okay, yesterday also you are able to get it. Now also you are able to get it, right? Now, here the main important is that the count is an action operations of a data frame, right? Now, here with the data frame, there is a command called show. Show means it is similar to a collect. Similar to a collect. Collect means what happens, what collect does? It collects data from all nodes and bring here. Show also same thing. So you can just show here, show your data. Okay. So when you show the data, okay, you can see this data. I have never seen, I never hope, but I would rather. And default, it uses one column called C0. Default is because it is structured data. You are working with the structure directly. When you are working with the SQL, you are working with the structured data. Even though your unstructured data is there at bottom layer, so it creates one column. Under that column, it holds a data. Okay. Now, if you want to see the structure, there is a command called a print schema. Print schema. When you use a print schema, so you can say simply see the structure here. See the structure. Now the print schema is a structure command which you can use. See the print of schema of the data frame, and show is a command to show number of. It's similar to a collect. Okay, show is a similar to a collect. Show, it shows a data like a table. Now you can also use a collect here. Collect means if you use a collect here, see output how it is. Bottom layer output it is. It's like a bottom layer output. I will tell you how it is. Okay. Now, for example, yeah. Where is that? Yeah. So here, for example, now I have created a data frame here. Like this is a my DF. It's like here. My DF, which has a structure. What is the structure? Default is single column is there. Because the file do not have any columns. Default that all data comes under one single column. It's like a single dimensional array. Now, if you use show command, okay, if you use a like my data, my df dot show, if you use, what happens that it pulls data from through this, pulls data from through data frame, and bottom layer is an RDD. Suppose if you use my df dot collect, okay, dot collect. Collect is not a data frame operation. Collect is a RDD operation. Okay, action operation. When you use a collect, you are bypassing data frame. You are pulling data directly from this place. Okay, you are pulling directly from here. That's what you are reading data in row objects. Okay, if you see this one, see the output here. Collect, you are getting what? Row. Okay, this is first row has this, second row has this, third row has this, fourth row has this, and column is C0. And if I use a show here, okay, see the difference output. Okay, you will get with the sum. Say you will get what some data structure type. Okay, data structure type. And there's a one more command. This is show is actually a Spark command. Okay, show is a Spark command, collect is a Spark command. And there is a Databricks has come up with a one more statement like a display. If you use a display, the difference between show and display, it's same as what show only, but display gives you a table format like here. Like C0, 1, 2, 3, 4 lines. Okay, not only you can also download, you can download this particular data also. Now I'm using the file purplecow.txt. I think there is a one more file we have seen, right? There are some more files we have seen here. Example, we have also seen like a people.json. And we have also seen a text file. Okay, this is a text file. When I say a text file, or you can say this is a page counts, is a CSV file. If I want to use a CSV file, okay, this is my CSV file. So we have project, we have article, we have request, we have byte served. 4 columns are there, and these columns are delimited by comma. Okay, since CSV means it is delimited by comma only. Now, if I want to read this file, okay, I hope I have already. In the same way, we have one more one. I'll go to whatever files I have uploaded now. Not here actually. People.txt is there. Okay, people.txt is also one file is there. I can read that file also. So I can use a people.txt. People.txt. Okay, people.txt is there. If I want to read this file, you can see it has some columns. People.txt has some columns. And if I want to read this data, I can display here C0, C1. The two columns are there. Okay. And Michael 29, Andy 30, Justin 19, Desai 45, Rohan something right. Some data is here. Now here I can see some columns also. The file has a columns. File has a columns. That people.txt has a columns. So now the column is also part of a data now. And default it fetches some, assigns some column name called a C0, C1, C2 like that. Now here there are some options you have to use. What is option first? Option number 1. Suppose I know that there are two columns. I want to use these columns, name and ages, as part of data structure. As part of a data structure. It means that I can use header here. Header, comma, true. Header, comma, true. When I use a header, comma, true, means you are skipping first row and considering that first row as a header of the file. Okay, header of the file. For that, we have to use the optional option spark.read.option into bracket header, comma, true. It means that if your file is having a column name, you have to consider this first row as a header of the file. In that case, header, comma, true. Header, comma, true. So now when I run this command here, okay, when I run this command here, so automatically what happens, it will display, okay, automatically this name and ages become a part of a data structure. Okay. Now if I want to use that, what is structure and all? If I want to use a structure of this, mydf.print schema to see the structure. Okay, to the structure. So here you can see there are two columns, name and ages. Two columns, both are string. By default, Spark returns column types are string. Column types are what? String data type. Default it's always string. Not only this tool, every tool by default it returns always a string. Now you know that the data is not actually different. Data is having ages. Ages are all integers. Okay, in that case you have to use one more option, dot option. Here you have to infer the schema. Okay, you are not inferring the schema, so you can infer the schema. In that case, infer schema, comma, true. Infer, comma, true means it means that since it is default, it is throwing default schema type. Data type is a string, but I know that my file has a column name. One column is having a integer. I want to return exact data type. So it means that in that case, you have to infer the schema. Okay, when you infer the schema, what it does, Spark go through the entire file, okay, and understand the data and returns its equivalent data type. Return its equivalent data type. When I run here, okay, sorry, somewhere it's wrong. Infer schema.
Sir, near the true one, semicolon.
Sir,
Sorry.
double semicolon.
Double semicolon.
Invert.
After true.
Yeah. So run this. Control D is the default running. Control and enter. Sorry, control and enter. It is running. So if you use this particular schema, run it. Now it is a double, because it go through the Spark engine go through that entire data set, and if 100% is an integer, it returns integer data type. 100% string, it returns a string data type. If it's mixed data, again it returns a string data type. Okay, so now in for the schema, so you know that it returns a data type as a integer or double or equivalent data type. Right. Now we know header, these are all optional. You may use, you may not use. But you know, it depends on what type of data you have, how data is coming. It's better you should what a return. It's a equivalent data type and all. Second, suppose if your file is CSV, correct, default is a CSV. Sometimes your file may come with the other than comma separated. In that case, suppose if your file is a different format, right? So there is one file in that case here. I don't know. 1 minute. Let me open one, just create one file here. Here the people.json purple. Yeah, user is there. Okay, let us take, there's one file called user. Let me have a, it's a delimited by okay, semicolon. Your file can be delimited by, your file can be of any delimiter, right? Default is if it is CSV, it's a comma separated. Now your file is delimited by semicolon. And this is what I have a column name also as a ID, semicolon name. Okay, this is a column name. This is the first ID, user ID, and name, username. I'll just save it, this. Okay, this I will upload. Okay, this what I will do, I will upload this file. 16, right? Will I save it? I saved here only. I saved this file or somewhere else, no? Download. I have saved here. Users, I have saved just now here. This is my file. Okay, I'll upload this file temporarily to show you practically. Go to data, create table. Okay, upload. I'll go to download. This is my file, users.txt is a file. Upload it. Okay, this is my uploaded. This is my path. I'll take this path and do some changes here. My notebook. Okay, now instead of this, I can use here. Now, you know that though it's a comma separated file is there, but my delimiters are different. By default, it is a comma separated. But when I run this statement, okay, so it gives you as a single column. See here. Because what is the reason? Delimiter is different. Default, it thinks that the columns are delimited by comma, but my file is having a delimiter as a semicolon. So in that case, I have to define one more option here. Option into bracket separator. Okay, then comma separator, whatever you have separator here. You have to mention that. A CP is a separator option, or delimiter also you can use a delimiter. Option, separator, semicolon. Now when I run this command, so now it is you are also telling to that columns are delimited by semicolon, and now if you run this one, okay, you have two columns here. You have two columns. because I'm telling separately to Spark engine. Okay, first row file is coming with a header. You skip that first row as a header. You consider the first row as a header of the file. Second, you are telling to engine also that please you can infer the schema. When you are inferring the schema, it will go through each and every data, and based on content, it returns data type. Third, you are also mentioning that the file is having a delimiter as a semicolon. Okay, and that you are pulling the data here. Now, same thing if you want to say fetch a data, you can just simply put mydf dot show. You can use it. This is data. Whatever you have executed, this data you can see. Okay, so just from your whatever files you have, you can just try on this. Just 1 minute. I'll come. Just 1 minute. Yeah. Okay. So now this is any questions here?
No, sir.
Okay. So now, yeah, coming back to here, the whatever I have shared with you. Okay, I have shared with you here. I think this one is I have shared. Right. Now, whenever you want to execute this, first, all of you go to includes. Okay, all of you can try with the include. Go to a data set. You run this query. You run this particular this one seat. I will tell you what is this. Don't at this moment don't think all those things. Just you run this. That's all. So this query is basically we are using because this is a Databricks material. Okay, so they have kept some data. Okay, they have kept a data in some places that's in S3. So this particular script, okay, will help to mount between that storage place and your Databricks. Okay, in this place like S3, Databricks, Corp, Training, Temp, in these folders, they have kept some data, sample data. I'm going to refer that data in my examples. Okay, I will give an example here, how it is. This is your Databricks. Okay, this is your Databricks, and they have kept on some, this is all part of cloud. So this is your Databricks. Okay. This is also in cloud. Huh? In this, you have a storage account. That is a cloud services. And you have a bottom layer storage. Middle layer is your say Spark. Okay. And this is a middle layer. Right. Now they have kept the data in some places. This is all part of your this one. You are using AWS, which is a part of cloud. They have kept some data in S3 bucket. Okay, they have kept the data in S3 bucket. So that path you can see, this is a path, whatever is there, this is a path. In this place, they have kept the data, which is here. Okay, which is here. Okay, this is S3. S3 means simple storage service. It's a storage account provided by AWS, where you can store unlimited amount of data. They have kept here. Now, this is a different service. Now, I want to read data from here to here. So it means that I can create a link here. From this particular place, I can create. I think you can. I think in you use a mapping, right? Drive. Suppose you, agar aapka storage is there in network, and you want to map to your drive. You create a mapping between your external drive and your computer. So it means if you click here, automatically it goes to there. So here you create a mount. This is called a mounting. Mounting means establishing the link between Databricks storage place and external storage. This is external storage. So this mount here, when you are talking about a mount, here they are given a mounting name. That is a MNT training. This is just a logical name they have given here. Okay, here this is actually a logical name. Okay, it MNT/MNT training means this particular part. Okay, /MNT training is a logical name which is pointing to this location where data is kept. So to establish the link between Databricks and say S3 bucket, we run that particular script. This is a script for establishing. Okay. So now once you establish the link, now go to the first part, reading data. When you are reading the data, they have kept different types of files over there. Okay. CSV file is there. CSV, comma separated value file. Then there is a Perquit file. Then there is a JSON file. JDBC, some database also there. They have kept some data also in the database. Okay, some raw data is also there, like unstructured data is also there. So they have kept this data. Now these exercises tells you how to read data from different data types. Different data. See, there is some CSV format, Perquit format. Okay, so these are all different formats of Apache. Perquit format. Perquit means it's a CSV, you know that, right? CSV, what CSV stands for?
Comma separated value.
Comma separated value, correct? Okay, by default in Excel, you save it as a CSV file. Because that files are delimited by comma. Text file, you know that, in which you can have a text data. Okay, having an extension of text. Same way, there's one more data type is there, that is JSON. JSON stands for, any idea about JSON? Are you reading JSON file in Python?
Yes.
What JSON stands for? JSON stands for Java Script Object Notation. It's same as CSV file. And JSON is lighter than CSV file. And JSON consists of both data and metadata. Both the data and metadata. Did you read a Perquit file in your Python?
Yes.
So Perquit is also one more format. So which consists of a compressed data. It consists of a compressed data. I think if you want to see the content of these files, you can see this. Somewhere else, like this is the data, right? So I have a JSON file. If you open a JSON file, yeah. If you open a JSON file, double click on this. What is this? Yeah, open with. How to open this file? Text file. This is a text file. Text file is this. Just it can be any unstructured data also. Then, if you are opening a Perquit file, which you cannot read it directly, you cannot read it directly. So this consists of a compressed data, and this can be read through the only application. Same as a JSON file is also same. It is having both metadata and data. Now, here, these are all different types of files are kept in that place. Now, if you want to read a file, okay, first let us say reading a, say, CSV file. So I think whatever I have told you, okay, here you can see that Spark context available in the as part of a notebook as a SC. SQL context is available as a SQL context. Hive context is also there. Now, Spark is, okay, as I said in 2.0, they made it as a Spark session. Okay, now if you want to print that Spark session, so you can just you attach this particular notebook to. So simple what you can do every time. So whenever you open a notebook, you attach this notebook here. Here you can see that you can attach to this cluster. Okay, now it's running cluster is there. Now, since you have executed only one time that particular mounting, don't execute this. Run and all. So now this talks about what? Just check about a Spark context. Okay. Then the Spark context, Spark has both SC plus SQL context, both. You can just see here, Spark is there anyhow. So that's a Spark session. And when you have that, you have even SC also, you have a Spark context also. I think this is about a documentation. When you are going to for a Spark, you can read a lot of documentation through the Apache. Now you are beginning with the data frame. The first part, Spark has a Spark session. Through Spark, you can perform multiple functions. Like you can read. Just now we have seen a Spark.read. You can also create a data set using the Spark.create data set. You can also create a data frame. That's what a Spark.create data frame. You can also create a empty data set. Okay, Spark.empty data set. Okay, if you are going to read a streaming data, you have to use a Spark.stream read stream. Right. So same thing. If you want to read any SQL commands, you can read a Spark.sql. If you are reading data from, say, table, you can use a Spark.table. Now in the entire things, what I want to do, I want to read a data first. First, I have to bring a data. That's what a Spark dot Spark. This is a Spark session. Short form is a Spark. Now Spark dot read. Okay, I'll use only Spark dot read. When I use a read, what I want to read. Okay, what I want to read here, I can read. It can read different types of files. Okay, read has a different types of file. You can just see that what are the files you can read here. You can read a CSV file, spark.read.csv. You can use. Data frame has a reader. Now Spark, if you are reading data from any database, you can use a spark.read.jdbc. Okay, these are all part of a reader. Spark, first we have seen a read part. Spark.read. Spark is a session. Then it has a method called a read. Read has a what type of data you are going to read. You can use spark.read.csv, spark.read.jdbc, spark.read.json. Okay, spark.read.load. If you are going to read a WRC file, spark.read.WRC, spark.read.perquit, spark.read.table. If you are reading unstructured data, spark.read.text. Okay, you can use also text file. And these are the options. Okay, option means I told you that option means if you are passing per parameter, like if your file is delimited by other than comma, then you have to use an option. First parameter is a key. That's you may use a SCP as a key, and value is a true. Okay, or suppose if you are making delimiter, okay, delimiter, you can use a delimiter or a infer schema. First, the infer schema is a key, true is a value, or that header is a key, comma, true is a value. That kind of value you can pass. So these are optionally you can pass value, but you can read different types of data here. Different types of data. Now, in this case, you can just test which are the files. So it is same as what your HDFS file, because I said your files are, okay, your files are here actually. So these files you can see through this particular mounting path. And I told you this is similar to your HDFS. Okay, similar to your HDFS. So in HDFS Hadoop file system, you are reading file na Hadoop FS minus LS something. So here also it's called a DBFS. It's called what a DBFS we call Databricks file system. It's called like Hadoop na. So here they have made same thing that's called a DBFS here, Databricks file system. So you can read a file. So here you can read a file. The DBFS path is there anyhow. Okay, in this path, so you can use just simply what you do that ls and give a path DBFS MNT training. Okay, this is your mounting path. Okay, percentage FS means file system. Then list means a list, like in Unix you are using a list command, and this is a path from where you want to see your files. So if you run this one, so it means that from this particular path you can see how many files are existed. Okay, here in this particular path, which is pointing, already I told you that this is the path, but which is pointing to S3 bucket. Okay, so this has two files. The first file is 0 records. Okay, page view by second dot perquit. It shows as a 0. One more file is there here. There's a page view _by second dot TSV. TSV means a tab separated value, like CSV na. So there's a TSV, tab separated value, which has around 26,000. Is almost 26 MB data is there. 26 MB data is there in this particular path. Now, if you want to see few records out of that, like in Unix, we are using head command, right? So here also use a head. Percentage fs head. So from this particular, I know this is a file name. From this file, I want to see some records from the top of the file. Okay, this is what I head and that particular path. When I use this command, so it will, you can see few records from the top of the file. Few records from the top of the file. So this is what few records here. So this particular file has columns. What are the columns here? Timestamp is a column, site is a column, request is a column. And these are the values. Okay, this is the actual data. Timestamp is 2015 03 16 something 955. Site is mobile and request is 1595. The request. So this is the actually data of Wikipedia. Okay, Wikipedia. I think whenever you access a Wikipedia site, okay, when you are accessing that date is being captured. Okay, maybe you may be logging, you may be capturing Wikipedia, or you may be browsing Wikipedia site either through your mobile or through desktop. Okay, this site means from where you are. This second column indicates that from where you are, browsing the site. What time you are browsing the site, and from which source you are browsing the site. When you browse the site, okay, I think when you click on one article, you will not get if the article is 10 page, so you will not get all 10-page article at one time. Okay, you may get only few articles, few part of the article. And like you, there may be multiple people are requesting for the same article. Is it true or not? You are also looking for one article. I am also looking for same article. Somebody is also looking for same article. So here, for that article, how many requests are there? Okay, it means that on 2015-03-16, in the sense 16th March 2015 at 009.55. At this time, through mobile, there are 1595 requests. If you look into this, another one, 2015-03-16, but at 10 o'clock. 10 maybe a 9:55 is a 9 o'clock 55 minutes. Maybe it's at 10 o'clock 39 minutes. So this time, 10 o'clock, there are again from through mobile, there are 1544 requests are there. 1939, timing is what? 1939. Okay, there is what? Through desktop, there are 2460 requests are there. Like this, now how many requests are coming? So it will capture those requests over here. Right. So now, like this is a data. Okay, there are 100,000 records are here. Okay, around 23 MB data is here. Now, if I want to read through Spark, okay, now this is a command. This is the path. First, I'm going to set a path in one variable. Okay, every time I don't want to use, I want to use that variable. Now, I'm using a my data frame equal to spark.read dot option. Option means that file is having a delimiter of a tab. You can see your file is a tab only. This one column, tab, second column, tab, third column. So here you have to mention clearly that dot option separator, comma, /t. /t stands for a tab. Then dot option header, because I know that file is having a header also. Also, it is a data. Okay, I want to skip first row, which is considered as a header. So that's what a header I can use it. Here, header, dot option header, comma, true. Now, at the same time, I want to infer the scheme, but I want to return exact data type also. I want to return exact data type. That's what option infer schema, comma, true. and file name is a CSV. You know that size is a CSV type. So, and path. Path means already this path. Rather using this path, I'm just making this variable into variable, and that value I'm referring here. So now, if I run this command, okay, it reads data and creates a data frame. Creates a data frame. Again, as I said, Spark is a lazy execution. Spark is a lazy execution. So you can't fetch data until you read, until you take an action. Until you take an action here, you can't read a data. Right? So now suppose I can, if I run this command, now I'm taking action here. What is the action? Count is the action. So when I run this command, I'm reading this data, plus I'm going to count a number of records. I'm going to count a number of records here. So this is what you can just, it takes time because there are a lot of records are there. So to count, obviously it takes some more time. It is not a small data. So data is 23 MB data. So it takes some time. This one. Okay, just here around 7,200,000 records are there. Okay, 7,200 records are there, and this is the same way it is. You can also use in a Scala. Okay, Scala. This is in Python. This is in Scala. Okay, down at this moment, don't think about Scala. Okay, again, you have to know Scala, how to declare. In Python, you know how to declare variable, right? Directly you can declare a variable and assign the value. Okay, so you can declare either variable, you can declare array, you can declare anything. So without any prefix definition. But in case of Scala, you have to use a val. Val means constant you are defining. Okay, val or where we are going to use. But at this moment, don't use this for your. Okay. Now you are reading a file and you are creating a data frame. And bottom layer, anyhow, you know that there is a RDD. Right. Now, if I want to show records, okay, if I want to show records, so here I'm going to store data. Okay, now if I want to show it, I can also show here. Show function I can call. When I run a show function, so you can see the contents of that file. You can see the contents of this file. So already you know that show, right? Just now we executed show. So here also you can see the contents of the file. And show is a Spark command. Data frame dot show. So that is a data here. Timestamp, site, request. Okay, suppose in Databricks, if you can also use a display within bracket. One of them we can use. Show is also action operation of data frame. Display is also an action operations of data frame. But a display, usually it is only specific to Databricks. Okay, show is, you can use a show is a Spark command. So only here it will show only in the form of a table. The output is same, but that's an ugly way it shows show command. Here you will find some kind of a this one table format. So once you show these records, okay, now, yeah, you can just visual. There are some options in Databricks. We have some options also. You can generate various reports. Okay, I mean, this is some kind of a, I mean, you can generate some graph also. Okay, this is not an actual exact query, but definitely if you write a query where it generates some graph, okay, like a proper graph. So you can see that as well. Okay, now if I want to see a data in table format, I can just see the same data in table format. Okay, it was bar chart. Now the same data I'm just showing in the table format. Okay, so now here what happens? So default, I think already one fetch only I am using, all infer schema or separator is a tab. Then also I'm header. First row I'm skipping as a first row as a header of the file. The output is this. Okay. Now here what happens? I think this is only one stage I'm using. So here they are given same thing in different way. Like first I have used proper. Then here I'm using a header. I'm using a header. Same command is same, but I'm using only header, no infer schema. They have gone by steps here. But everything I have mentioned in one place only. Okay, here. Okay, this. Okay. So everything I mentioned, option 1 also I have mentioned, option 2 also I have mentioned here, option 3 also I have mentioned. But if you go down, the same output is in different step by step here. First, use the header. Spark.read.option. Okay, option is this one. The second option is a header, comma true dot CSV and print schema. Now you are seeing the schema here. String, string, string. Because why it is string, string, string? Because your data is there here, right? What type of data? You can see the data here. Some numerics are data. Here some date is there and some distro. But here everything is a string. Why it is? Any idea? Why it has written string? Yeah. Are you there, all of you?
Yes,
Yes,
sir.
sir.
Why it has written as a string now? This is your command. Spark.read.option separator tab option header true, then path, and I'm printing a schema. And it has given that timestamp string, site string, request string. What is the reason? If I want to
in text format.
text format is 1. Okay. Now if I want to return its exact data type, what I have to make here? What changes I have to make here? In this query. What changes? Suppose if I want to, I know that there is a column called request. It has an integer value. Then there is a timestamp value is also there. So I want to return exact data type. What option I have to add here? What option? Here I used option, option separator, options here. One more option is there. What is that option? To return its exact data type. Just now I have shown here. What is the option additionally I have added here into infer the schema? What is the option I have added here? Have you seen this option? Infer schema.
Infer schema.
Infer schema. Here there is no infer schema. That's why it is throwing all data type as a same. If I add one schema here, okay, dot option, okay, dot option, infer schema, comma, true. When I add this now, automatically these data types become changes. Because when you use infer schema, what it engine does, Spark engine does, it go through entire data set. It scan entire data set and return its equivalent data type. Return its equivalent data type here. Now when I run this, it returns its equivalent data type. So here we know that some numbers are time type, timestamp type, and some numbers are what? Double or integer type. So timestamp is also one data type, string is also data type, and even you can see that double or integer is also data type. So now you can see here. First data, which is like a timestamp, it returns a timestamp data. Second, anyhow, is a string data type. Third is an integer. It returns exact data type also by using infer schema. Whenever you use an infer schema and it uses two jobs, I think you can see it uses two jobs. Without infer schema, it uses only one job. If I take out this, and if I run this query, see how many jobs it uses? It uses only one job here. You can see here only one job. Because there is no question of returning its equivalent data type, right? How do you know it's to return? In order to return equivalent data type, it has to scan entire table. Okay, to scan entire table, it requires one more extra job. So when I say just by adding option infer schema, okay, it uses two jobs here. One for fetching data, other for what? Scanning entire data set. Okay, scanning entire data set, I can use just option. Otherwise, if I don't scan, return data types are what? A string only. All are returns a string only. Okay, so that's why it is taking two jobs, and also timing is also more. So here 20.46 seconds it took. If I take out this, okay, it takes very less time because it takes hardly how much time? 1.10 seconds. Okay, just by adding infer schema, it means that your one job will be there for only scan entire data set and return it equivalent data type. For that, it uses an extra job which takes time, time here. So now again, it takes time here because it has to scan entire table, return its equivalent data type. Okay, so that's what we are using an option. So to avoid this, so what we can do, we can, if you know a schema, you can define a schema. If you know this schema, already I know this is a timestamp, site, and requester. So this is a schema. So I can define also that schema here. Okay, so when I define a schema, okay, I can define this way. I think these are notes are there. Here you can read these notes because here I think they have given why it took more time and all. Whatever I explained, the same is there. I told you that why were there two jobs. Already I told you two jobs are used. One, to return data type. Second one is to scan entire data set. It uses two jobs. Now, as I said, to infer schema itself is using one entire job. So what if I can define a schema also? If I know the schema, I can define schema. Usually to define a schema, in Python, we define schema like this, right? This is a way to define a schema in Python. Is it correct? Whatever you've done in your Python statement, Python class. Have you defined the schema in Python?
Yes.
Is it the same way you have defined the schema? Struct type. Okay, then struct field. Whatever that you have defined the schema here, timestamp, string data type, struct field site string type, struct field request integer type. And this is the structure, and that is the schema you are defining. When you define a schema, okay, it should match with your actual data. Okay, you define the schema. So rather inferring the schema, you can refer that schema here by using here just dot schema and schema name. Okay, dot schema name, you can refer the schema. One is you can infer the schema, which takes more time. Okay, then second one is to avoid that schema more time. What you can do that you can define a schema, and you can that is user defined schema you can define it, and that you can refer here in your query. Okay, spark.read dot option header comma true option separator comma tab and schema CSU schema and path. Now anyway your schema is already defined, so it does not scan. It does not scan because it uses only one job. Okay, here because the schema already are defined, no question, it refers that schema to fetch a data. That's it. Okay, so this is how you are reading data in case of what CSV file. Same thing if you want to read a say Perquit file. Very simple. Once you know one part, second all are easy. So second is what you are reading. There is one more Perquit file here. Okay, there is a Perquit file. I think this talks about what say what is Perquit file and all. So it's a free open about Perquit file is a free and open source. Increase query performance over a row-based data storage. Because whenever if you want to increase the performance of your any system in Spark, so you can store in Perquit file. You can also fetch a data in Perquit file, which is much faster. And it's a column-oriented data store. Okay, it's a column-oriented data store. So if you want to know more about Perquit file, so you can click and just see that what is this Perquit file. So in the same place, they have kept some Perquit files also. Okay, you can see there's a file called okay, here there's a file. So you can see the Perquit dot Perquit is there. Dot Perquit, here also dot Perquit, here also dot Perquit. There are so many Perquit files are there. So means that partition files are there. So we want to read them also. Perquit data, we want to read it. There are Perquit files which we want to read this Perquit file also. So here, when I read a Perquit file, very simple, you can use it. Okay, how do you use it? Spark.read. Suppose if I want to define a schema also, I can define a schema. Like previously, how we have defined the schema. So I have to define a schema. Whenever you define a schema, I'm using data type, SQL data type. So when I'm using SQL data type, I have to infer a schema. I have to import some libraries. That is SQL types libraries. SQL types libraries I have to import. Then I'm defining a schema here. Perquit schema equal to struct type. This is the way you define schema in Python. Okay, then that schema I'm going to refer here. And file name anyway, it's a Perquit file. Dot Perquit. So when I use a dot Perquit, so I can just simply print the schema here. Okay, so now here Perquit file is not defined. Right, I think it means that before I should execute the first command. This command I have to, because I have to define, because I'm referring Perquit file. So this file I'm referring here in this case. In this case, I'm referring that file so that first I have to assign that value. First run this shell. Run this shell. So after running this shell, so you can see that this is actually that file has this particular structure. Now you can define a structure here. because to avoid a job, to avoid one job, I'm defining a structure here. Then I'm reading this file. Okay, when I read this file, so you can just easily, you can fetch a data also. Okay, you can use schema or also you can use a show also. Use a show means you can also running, seeing the data. So seeing the data, show means see the data. So here the difference between reading data from Perquit file, reading data from a CSV file, both are same. Spark.read, okay, dot, here only options are not there. Because in options means that file, the CSV file has options or JSON file has options. So here no options because it's a compressed file. You can use straight away spark.read dot. If you define a schema, dot schema, then dot Perquit, and you can just read and create a data frame. Okay, so you are reading this file and you can just, you are seeing the data also. Okay, you are seeing the data. Okay, this is what a Perquit file you are going to read. In the same way, if you want to read a JSON file, here JSON file is there. Reading data from a JSON. JSON is a, as I told you, JSON is a JavaScript object notation. JavaScript object notation. So that holds both the data and metadata. So you can also refer a JSON file. This is just a JSON file they have given. You can see this file, fs.ls and .json. .json is snapshot dot 2016-05-26.json. This is JSON file. So first attach to the cluster. Okay, it is attached. Now you can run this. Okay, run this one. And after running, if you want to see few records, okay, this is JSON file, which is there in this particular MNT training path. And there are 422, 431, which is 4,222,000 records are there. Okay, now if I want to see few records from the JSON file, okay, JSON file is used basically for nested data. Whenever you have a nested data, so you can use that JSON file. So you can see the content of JSON file is this. Can you read this data? You can read it like is robot, false, channel, the channel name, timestamp. Everything it holds both data and metadata together. Okay, this file, if you want to bring in some structured manner, so what is spark.read.json? Simply. Here we are reading spark.read. Whether if you are going to infer the schema, dot option, infer schema, dot JSON. And you are creating a data frame. Wiki edits data frame equal to spark.read.option, infer schema, dot JSON, JSON file name. And if you want to print the schema, so you can see that print the schema. So JSON is very much suitable for a nested data. If you have a nested data, so JSON is being used here. This is actually data, JSON data. This is actually contents of data, and this is a structure of this JSON data. Whatever the file we have seen, this is structure. Because print schema I am using this is for a structure. And if you want to see a data, so display, or you can say show. One of them you can use it. Display means it shows in a table format. Show means it shows us some kind of the show. As I told you, show is a schema. Show is a Spark command. Display is a Databricks command. Okay, if you want to take out this, so if you use a show and run it, so you can say this is a data. Okay, this is a data of a JSON file. Or if you want to display, if you use a display, because too many columns are there now. That's why you can use a display, one of them. If you use a display, you will see the same data in table format. Like channel is column, these are the channels, comment is there, delta is there, flag is there. So this is nested data. Okay, geocoding is a column. So in this city, country, country code. So this is kind of a nested data you have. Okay, so like this, you can read data from CSV, you can read data from text file, you can read data from JSON file, you can read data from a Perquit file. Okay, so now what I suggest all of you that before you come to the class, you just execute these statements. Okay, you read a CSV file, you read a Perquit file, you can read a JSON file, you can also read a table, you can read it through the RDBMS. There's a MySQL database is also there. From there also you can read the data. So you just, before you come to in the afternoon, complete this. Same exercise you can complete. Okay, now you know that reading data from different sources. So once you bring a data from different file formats, now we have to process the data. Okay, that's what like an ETL tool, we can process the data. Okay, to process the data, as I said, we have to use a different transformation operations. Yesterday we have seen, right? Like transformation operation, action operations. So there I want to use all action operations and also all transformation operations. There are set of transformation operations. Then there are set of action operations are also there on data frame like RDD. Here also we have them. So we will complete them in the afternoon class, that transform operations. First, only you read the data. Read the data and create a data frame. That's all. Is that clear?
Yes, sir.
Yes, sir.
So before you come to a class, you complete this first exercise, this exercise. Reading and writing data. Only this, just you need not to do anything, just you execute, read that state, whatever the notes is there. Whatever I explained, same notes is here. Just you run each node shell. That's all. And I will start here. When I come here, I will just take this part very quickly. And tomorrow we'll go for this part. Only one or two I will take it. Next, you have to work on that. Okay. So shall we meet at 2 o'clock, 2 or 1 o'clock? I think, can you give me one of your phone number? So I can say 1 hour before shall I call or how it is? 3 become too late. How do you manage then? Shall I call one of you? If 1 hour before, not immediately, 1 hour before. Suppose if I want to start at say 2 o'clock, I will call at around 12:30.
Okay.
To whom shall I call? So that he can inform to everyone.
Shubham.
Shubham,
Can
sir.
you give me a number?
Yes, sir.
Give me number, because anyway I'm coming up to Sadashivpet. So almost near, again coming back 15 kilometers, again coming back to 15 kilometers, 30 kilometers I have to travel. If I finish by 1 o'clock, I know that if I'm going to finish by 1 o'clock, then I will call you at 12 o'clock or 11:30. Or if I'm finishing by, if I want to start at 2 o'clock, I will call at 1 or 12:30. So you have enough time, I have also enough time.
Okay, sir.
Okay.
Phone number on my chat.
Okay. So Shubham. So he can inform to everyone, right?
Yes, sir.
Okay. So what I will do, 1 hour before I will inform you. So that even if you are coming from different places now, so or even if you are busy with somewhere else, okay, so at least you have 1 hour time. Okay.
Okay, sir.
Because
Shubham,
based on that,
please.
tell me.
No, sir, I'm asking Shubham to inform us on WhatsApp group.
If you have group, you can. If you have, do you have a group? If you can add
Yes, sir. We
me,
have WhatsApp.
do you? If you can add me, you can. I will just inform there also. Or if you are not having the rights to add me, no problem. I will inform to Subham.
Yes, sir. It's the admin is Utkarsha ma'am.
Okay, no problem. So I will send any message or call to Subham.
Okay, sir.
Okay, if I will tell exact time what time I'm going to start. Okay, 1 hour before I will tell you. Okay, preferably 2 o'clock may start. Huh?
Okay, sir.
Now we have made at 3 o'clock. Now just 1 hour, so 4 o'clock we can finish it. Okay then. So I will call you Subham.
Okay, sir.
Okay, please inform to others also whenever I call you.
Shubham, please inform us on time.
Yeah. Okay. Okay then. Thank you. We'll meet in the afternoon.
Okay, sir. Thank you.
Thank you, sir.
Thank you so much.
Okay, sir. Thank you, sir.
Yeah, thank you. Thank you.
Thank you.
Yeah, thank you.
Thank you, Shubham Kate.
Thank you, Shubham sir.
Shubham,
Data
sir, please
scientist
inform us
Shubham.
on right.
Yes. I will inform.
Scientist Shubham, please inform us.
Shubham, I think sir is calling.
Senior data scientist, not a
No.
scientist.
Yes.
Respect Shubham.
Shubham sir is calling you, I think. My phone is not my.
Shubham, please pick.
Shubham, please pick up the sir's call. Call is recording. Okay, bye. Good night.
Bye, love. Bye, love.
Bye.